Before I start, okay. That's Friday. Okay, 185. Let's go. Some of you already did this. If you did, good for you. How long is the bridge they want to ask? They're asking us, right? Yeah. Is in the morning on Friday. Still, I'll still try Thursday. Okay. I will inquire about that. I just had some students come and ask me to sign a permission slip. So write this down, okay? Something like this is not exactly like this on the test, but this same kind of train of thought will be required, okay? Pay attention now, 185. So how long is the bridge? What do we know here? Allow me to highlight, if you've noticed, right, like these two sides are the same and that pattern continues, right? So I'm just going to focus on this one right here. I'm just going to focus on that. If you have a pen, write this down. This is 11.3 feet, right? Did you know that? 1 is feet, 2 markings is inches. If that ever comes up, then now you know, right? And I'm told that I don't know if you noticed this, but the height here is 8 feet. You can write that in, 8 feet like that. So, and you can tell that this is going to be a 90 degree on either side. Doesn't matter. So what I'm going to do is I'm going to cut one of these out. I'm going to split it. Would this be a symmetric or asymmetric triangle? Pay attention, guys. Symmetric, because both of them are the same. So I can actually cut it in half. So if I find this, I can just double it and find the whole thing, correct? Okay, so let's draw this out. So take one with you and just a small little sketch here. This is 8. This is 11.3 feet. And let's call this X right here. What can I use when I have 2 out of the 3 sides and it's a right triangle? Right, Pythagorean theorem. What is this? Leg or hypotenuse? Yeah, you know how they always tell you A, B, or C? It confuses a student sometimes. Say, well, wait a minute, it's A, but you call it X, right? Just leg, hypotenuse. That's all you need to know. So in this case, we're missing one of the legs, so we take the square root of 11.3 squared minus 8 squared. I hope you're writing this down, right? So then let's compute that. That's 63.69. I like that most of you are showing step by step, you're showing your work. Did I talk about rounding to 4 as you're working? Did I do that? If you didn't, if you did this on your own, you didn't, not a big deal today, but you want to kind of get used to that. So we know now, if you have a different highlighter, you take this one and you just tell yourself that you just found that stretch right there. Okay, how many of those stretches do we have? 1, 2, 3, 4, 5, 6 of those. We have 6 of these. So I'm just going to go ahead and go times 6 sections. Did I clear it on my screen? I did. Should have left it. Times 6. So that is in fact 47.88. You can put one mark like that, or you can just put feet. That is fine. Okay. So we use Pythagorean theorem. Some of you probably might have used cosine law, right? Like you can use all of those still. Don't hesitate to do that if you prefer. Okay. Calculate the interior angles of triangle ABC. Where is triangle ABC? If you have a different highlighter, right? A, B, C, it's this one here. Okay, that's the one that's being talked about. But you would have to agree that these are the same, right? It's just flipped upside down, right? The pattern continues. Anybody do the work there? So for ABC, we kind of need to know. Let's do that right here. Let's draw the upside down triangle. We know that this is what? These two sides are the same. So they're 11.3. Write that down. And what about this part right here? We found half of it right earlier. So just times it by 2. You take this, times it by 2. That's 15.96. 15.96. So what are we going to do if we have three sides? What are we going to try to check? We're going to check for, this is actually angle A right here. I'm going to check to see if this is an obtuse angle here. So we're going to go 11.3 squared plus 11.3 squared minus 15.96. Did anybody do this already? Perhaps you already did that. So I do that, and you get a positive answer. This is positive 0.6584. So what do you know now? This is going to be acute, right? Acute angle. So we can name this an acute. When it comes to angle, we are now certain there's no obtuse angle. Does that make sense? I just want to go home. I'm hungry, right? I wonder what's for supper, right? That's what you're thinking. It's acute because I did the check. I just did the top part of cosine law, right? The top part. And then what do I know about the sides? Obviously, it's an isosceles. So that one shouldn't be a stretch, right, to get that one right. So acute isosceles. You have another highlighter, right? That's why I know that it's acute, because my answer ended up being positive. If that's negative, then it's obtuse. Okay. Next, classify ABC. Why again? Oh, okay. So this goes here, right? This is an acute isosceles. I already did that. Okay, I was going too far, right? I was going jumping to the conclusion there. ABD right here. Let's just imagine it. ABD, this one right here. We know that that is A, right? Let's go question. This one right here is the exact same one as this one right here, correct? Angie, focus here. Focus. This, and we know that all three sides are different, so that's a scalene. Okay? Scalene. It's a right scalene because it's the same as the one I just worked with, and I figured out. Some of you are probably like, Mr. Rickson, that's very close to 8, right? This is very close to 8. Could it have been possibly an isosceles? I will make sure that doesn't happen. I don't like it that it's that close, but I would just say go by the number you got, right? Whatever this is, if you use all decimals, if you use cosine law, whatever ends up being right 8 when you round it, then you go with isosceles. I got slightly different, so I'm going to go with scalene. Okay. I'm going to make sure it doesn't happen. I don't like that it's that close because it's a bit confusing, right? So it is what it is. Okay. I will give you one to try before I go on to quadrilaterals. So you remember that section up here that is blank space here? I actually have a question I want you to copy down there. I just need to find that. Give me 1 second. There's a sticky note that I prepared right here. So that blank page here, I'm going to ask you to write this down, okay? So first of all, we're going to say classify triangles W, X, Z, triangle W, X, Y, and triangle X, Y, Z. Weird letters, right? But hey, here it is. Here's the diagram. Should I do it in the middle? I'll do it more in the middle here so we can work around it. So do one of these. It's asymmetrical, so it's a little off-centered. We're going to make an imaginary line down the center. We're going to call that a right angle. Follow me with the letters, okay? W, X, Z. And then this point where the dashed line comes down, we're going to call that Y. And here are some numbers. 45 inches, 60 inches. This is 51 degrees here. And the whole thing from end to end is 70 inches. Okay. Pretend like this is an AC right now, except for you're going to keep it. Obviously, it's in your books, right? Back in the COVID days, I would have been like, hey, take a picture and submit this, right? Not today. Give it a, you don't want to hear it, just plug your ears. My first order of business is going to be to find this angle up here. I noticed that it's side, side, side. So check angle X. That's what I'm going to do here. So I basically will check 47 squared plus 60 squared minus 70 squared. And so that gives me 909 positive. Okay, so this is going to be an acute angle. I actually want to solve. I actually want to go ahead and solve for that angle as well because I needed to figure out this angle here. Okay, I might as well. So I'm going to stop there. I'm going to go times, right, 2 times 47 times 60, right? Like these two sides come back here. 2 times 47 times 60, that's 5,640, which in turn is 0.16. That keeps going, right? So to find angle X, I'm just going to go cosine inverse of 0.161, right? So take the inverse of cosine, and that's 80.73 degrees. Okay. Let's go ahead and find W right away, because if we have this and we have this, let me just highlight that. This angle is that whole thing up there. We can find W because we've got 2 out of the 3. So angle W is 180 minus 51 minus 80.73. That is 48.27. These are all important numbers. Okay, so W is there. Everything is where it's supposed to be. Okay, we found it. I think we're ready to classify. Um, the only thing here, the only problem for me is I need to know if these perhaps, does it matter if I find this part right here? I don't think so. So we're going to go WXZ, right? We're not going to say it's equal to, but WXZ is that big one. That is definitely an acute scalene because all sides are different. Triangle WXY. WXY is this one. It's definitely a right. And triangle XYZ is definitely right as well. Because if you have a box here, you're guaranteed a box on the other side. They add up to 180 along that straight angle. Okay. If go with me over here. If this is 51, right? Stay with me for a little longer, guys. If this is 51, what is this just up here? Right. 180 minus 90 is 90. Minus 51, 39, right? 39 degrees. So we know based on that that all three angles are different, therefore it's scalene as well. Oh, sorry, I kind of jumped the gun here. This is 48, 27. We know that these are going to be slightly different. So this is also right scalene. Okay, they're all right scalene. Let me just go. This is 4173 here. 4173. Oh my goodness, this is a really, really messy page, right? Can I just tell you one thing? Look at this page. Look at this page for tomorrow. I'm gonna draw from this page for tomorrow's AC. Okay. Thank you guys.